Okay, I was in a little bit of a rush in the last video to make sure to finish, so I want to wrap up and make sure we're solid on the adaptive immunity. So adaptive immunity is all about the lymphocytes, either B cells or T cells, and that targets very, very specific um, invaders, right? So the B cells, anytime they have a antigen receptor that binds to a particular epitope. Now, keep in mind, millions of B cells. So you got to get lucky to have this particular B cell that perfectly matches this particular epitope, right? But that's going to cause it to become active when those bind, right? So we're thinking cell to cell recognition there. And so the B cell replicates, makes memory B cells as well as mature B cells that secrete antibodies. Humoral is all about the B cells, is all about the antibodies. When we get onto cell-mediated immunity, that is when we're thinking T cells. Same thing here. The T cell has to recognize the antigen, but in this case, it's going to be on this like presented piece right here. The antigen is not part of the cell that it is on. The antigen was broken up from the pathogen that got engulfed, digested, broken apart, and now this antigen presenting cell is showing off, hey, look what I found, and then the T cell is going to bind to it complementarily. So it's got to be the right T cell. There's going to be millions of T cells that this guy is going to have to be like, do you recognize this guy? No. Do you recognize this guy? No. Do you okay, right? So eventually the right T cell that has the complementary receptor to the antigen is going to be found. That's going to activate the T cells to then make cytotoxic T cells that break down anyone else who is displaying that antigen. Okay, so that's the B cells and the T cells. Those are both part of the adaptive response. And then we talked very briefly about the T helper cells, which are just specialized T cells. They activate the same way, but now instead of dividing and specializing to make cytotoxic T cells, these are the helper T cells. These are the guys that are going to go around and then activate the B and the T cells. Okay, I want to mention something about this. We already talked a little bit about HIV, human immunodeficiency virus, and the reason that it causes the human immunodeficiency is because the virus is only going to bind to T helper cells. And that means the virus is only going to infect T helper cells and only going to kill T helper cells. Now, if you don't have T helper cells, the odds of you getting a B cell that is complementary to the antigen or a T cell that is complementary to the antigen is pretty low. So the T helper cells really facilitate both arms of the adaptive immune system to work. And when you don't have many of them because they've been killed by HIV, that means you start showing signs of acquired immunodeficiency syndrome or AIDS. It means you don't have a very strong immune response because you don't have many cytotoxic T cells or B cells that are becoming activated. Okay. So now taking a look at immunological memory. That's what's great about immunity. The whole idea behind immunity is that you are specializing your cells to respond to one very specific threat so that the next time that threat comes about, you can like eliminate it pretty darn quickly. So let's say that we've got this antigen. Maybe it's to a particular strain of the flu. A little bit of exposure to it early on is going to give you a little bit of a result, a little bit of a response, I mean. But now you have memory B and memory T cells. So after you've had your initial sickness, the second response to it, you're going to have those cells ready to go, those memory B and memory T cells ready to clone themselves and make a huge army to combat it before you even notice that you've contracted it. So what did I say? Cold, flu. Okay, particular strain of the flu. You get it one time, just a little bit of it, or you get it and you have just a little bit of an immune response. The second time you have so much of an immune response that you never notice the symptoms because the virus doesn't have a chance to replicate enough in you to make you feel sick. Now, that being said, if the first flu virus that you were exposed to triggered antibodies to a particular part of the flu, and then you get a different strain of the flu or a different strain of the cold, the second time you can still have a low response to a different antigen. This is why people can get the colds so many times, because there's so many different variations of it. So the first time you get one cold, you get sick. The second time you get that exact same cold strain, you're not going to notice. Your body's going to be able to fight it off really, really quickly. But because there's so many strains of the cold virus, it seems like you get sick like every 2 weeks. Maybe that's just me. Don't have kids. Okay. So finally, we need to talk about types of immunity. We can talk about active immunity, and active immunity is anything that leads to an immune response. This right here. And because it leads to an immune response, that's going to allow for the production of long-term protection. So exposure to the pathogen leading to the production of your B cells, meaning you're getting memory cells, meaning that you have lifetime or long-term immunity. And this can be natural. For example, exposure to a disease. Once you get a flu virus, if that's the same strain that's going around, then you're not going to get it again. Or it can be artificial, such as in vaccinations. The idea behind a vaccination is that you give individuals pieces of the virus or pieces of the bacterial infection, and that causes an immune response. Now, it's not going to be so much of go back a sec there. Okay, you're not going to get sick from it. You don't get sick from the flu vaccine, for example, because guess what? There's no living particles, or there's no reproducing particles in there. What you are sometimes getting is symptoms of illness because you do have some immune response to it. But because there's nothing reproducing, there's no pathogen actually in you, you don't get sick. Okay? Anyway, but then the second time you're exposed to it, like when you actually are exposed to the real flu virus, if it's the same strain, then you're going to be able to make the B cells and the T cells so rapidly that you'll never even know that you had been exposed to it again. That's active. You make you mount a response. In passive immunity, you don't mount an actual response. You just kind of passively get antibodies without ever encountering the thing that would have gotten someone sick in the first place. So that can be natural, right? Either fetuses or babies are going to get those antibodies from the mother, and that's what keeps them protected against infection for usually the first 6 months or so. You can also have passive, that should be artificial, not passive. Right there, artificial. So you can have artificial passive immunity, which is you getting antibodies in an artificial or medical setting. And so, for example, antivenom is just a whole bunch of antibodies that are produced against the venom. And you don't have enough time, if you've been bitten by a snake, to make antibodies to neutralize that toxin. So instead, you're given antibodies that are going to work really quickly to neutralize the snake bite. So the problem with passive immunity is that it's going to be immediate, but it's not going to be lifelong. Whereas active immunity is lifelong or very, very long lasting, but it could take a while to develop. So if you've got questions, hit me up. Enjoy the rest of your snow day, and thank you for watching.